Hey there, let's talk about programming. You know, the tech world moves incredibly fast. It feels like there's a new language, a new framework, or a whole new way of doing things popping up every single day. The ground is just constantly shifting under our feet. So the big question is, how do you keep up? Not just survive, but actually get ahead. Well, today we're going to build a real plan to keep your skills razor sharp for the next decade.
And if you're feeling a little overwhelmed by all of it, you're definitely not alone. It's like every week there's some new must-learn technology. Should I drop everything and go deep on Rust? Or maybe master the latest AI model? Wait, what's this WebAssembly thing, and what is it even for? The pressure is real, and that fear of being left behind, yeah, it can be totally paralyzing.
But look, this isn't going to be just another explainer with a long list of hot new trends. Nope, today we are cutting right through all that noise. The goal here is simple, to give you a clear, actionable framework, a concrete plan you can actually use to guide your learning and your career, not just for this year, but for the next 10.
So, before we jump into what to learn, we have to understand why. The real trick is to look past all the short-term hype and start to see the major fundamental shifts that are really shaping our industry. These are the signals in the noise, and they're what we need to pay attention to.
First up, memory safety. This is no longer some niche optional feature. It's fast becoming the default expectation for any critical system. You've got languages like Rust and Go absolutely leading the charge here, and what they do is incredible. They eliminate entire classes of security vulnerabilities and nasty bugs right at the compiler level. This is a fundamental shift. We're talking about building reliable and secure software by design, not just by accident.
Now let's talk AI. What's really fascinating about its impact isn't necessarily new AI-specific languages. The biggest change is how AI is being embedded directly into the tools we already use every day. You know, think AI copilots right inside your editor, your build systems, and your CI/CD pipelines. They're writing boilerplate code, generating tests, and even flagging security issues before you can even commit your code. It's a huge productivity boost.
Trend number 3. WebAssembly, or WASM, is officially breaking out of the browser. It's quickly becoming the universal runtime for things like secure plugins and edge functions. And because it's sandboxed, it lets you run code from basically anyone, anywhere, without risking the security of your main application. For accessibility and security, this is an absolute game changer.
And finally, with the explosion of AI, understanding how to use GPUs is becoming non-negotiable. Now look, you might not be writing low-level CUDA kernels every single day, but having a solid mental model for how GPUs work, understanding things like memory bandwidth, batching, and vectorization, that's becoming table stakes if you want to build high-performance AI-driven applications.
Okay, so those are the big signals pointing to where things are headed. Now, let's get practical. How do we translate all that into a real strategy? What specifically should you be focusing on learning right now to make sure you're aligned with these trends?
The goal here isn't to learn every single language under the sun. That's impossible. Instead, you want to become a pragmatic polyglot. That means having a small set of really powerful complementary tools. So step 1, master an infra language like Go or Rust for building fast, reliable systems. Step 2, master your productivity languages. Python, which is the undisputed king of AI and data, and TypeScript, which is the language of the modern UI and the edge. And finally, you got to understand how they all plug into each other at the lower levels through C and C++ interoperability.
Okay, so if we put all of that together, your modern skill set really has 5 key layers. At the bottom, you have the timeless fundamentals, things like concurrency, distributed systems. These never go out of style. On top of that, you have the language stack we just talked about. But to be really effective today, you also need AI literacy, so understanding concepts like retrieval augmented generation, or RAG. You also need to be a pro at modern operations and tooling, and have a deep grasp of security, from threat modeling to modern authentication. Just think of this as your personal roadmap.
You know, a great strategy is pretty useless if you don't act on it. So how do you actually learn all this stuff? Well, the answer is a repeatable, project-based 90-day cycle. It's designed specifically to turn these abstract concepts into real, concrete skills.
So here's the plan, and you can just rinse and repeat this every quarter. For the first 3 weeks, you're going to build a modern AI app. That means touching TypeScript on the edge and Python for the AI service. Then you'll spend 3 weeks deep in the systems world with Go and Rust. Weeks 7 to 9, you tackle a WASM plugin system. And then you cap it all off with a little mini project on the GPU.
This cycle is designed to systematically cover every single one of those trends we talked about.
And here's the really important part. Don't just build these projects, ship them like a professional. What does that mean? It means adding tests, packaging your app in a container, generating a software bill of materials or an SBOM to track your dependencies, and signing your artifacts. Trust me, going through this process is just as valuable as the coding itself because it builds the habits of a modern, security-conscious engineer.
Okay, finally, let's talk about the glue that holds all of this together. A plan is great, but what's going to sustain it for a whole decade is having the right mindset. These are the underlying habits and philosophies that really separate the good engineers from the truly great ones.
You can almost think of these habits as the operating system for your career. Always, always measure performance. Don't just read the docs, go read the actual source code. Automate the boring stuff with AI. Make durable technology bets based on those signals we identified. And this last one is so important. Own a domain.
This might be the most critical habit of them all. Look, being a great programmer is good. But being a great programmer who deeply understands, say, fintech, or climate science, or robotics, that person is unstoppable. Technical skills, to some degree, can be commoditized. But that deep domain knowledge, combined with your technical expertise, that's a force multiplier that just compounds over your entire career.
All right, let's bring this all home. We've looked at the signals, the strategy, the action plan, and the mindset. So what does this all add up to? What is your ultimate competitive edge in this crazy, rapidly changing industry?
It's this. Let's call it the modern engineer's edge. And it's a combination of three key things. First, a deep understanding of systems, which you build through hands-on projects with languages like Go and Rust. Second, that compounding domain insight, where your tech skills make you a true expert in a specific field. And finally, AI-augmented speed, using all the modern tooling to automate, accelerate, and just plain improve your entire workflow.
So there you have it. You have the framework, you have the action plan. The only thing left to do is start. The real question isn't what the future holds for tech, it's what you are going to build with it. So let me ask you, what will you build in your first 90 days?